All right, so we're also going to do 20.3 similar figures. That's because it's applying a sequence of transformations and determine the pre-image and image are similar. So with similar figures, the shape, the figure will be the same size or same shape, but not necessarily the same size. So this is why we had to do it separately from 19.5. Similar and congruent are a little different. The sequence will cause it to change size. All right, so we're going to identify, just like 19.5, a sequence of transformations that transform A, this little guy right here, to B, this one here. So it's obviously gotten bigger, right? So what we're trying to do is determine if they are in fact similar. Can I make A become B? That's what we're trying to check. That's what's going to make them similar, is can I make A become B? So it's clearly gotten bigger. Remember from 20.1 dilations that when they get larger, it's a dilation, and that means we're going to have a factor that's bigger than 1. So we would need to check. So this is 1, 2, this is 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. So if it goes from 2 to 4, that's a times by 2 scale factor. So I'm going to dilate by a scale factor of 2. Remember our rule, x, y goes to, we go 2x, 2y. Okay? So these are all at 1, 1, 1, 1, 1. So I'm going to put them at 2, right, times by 2, 2, 2, 2, and it's going to be this box right here. See, they're at 1, 1, negative 1, 1, right? So now they're all 2's. So at least now I know it's the same shape, but can I get it over there? Well, the nice thing is this is just a translation. And so 1, 2, 3, 4, 5, 6, up. I take the corner, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. And 4 right. And so we would say xy goes to x plus 4. Remember, right, left is x's, and right is positive. And then up would be plus 6. And we would then at every point there, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So yes, they are similar because I was able to make A become B using transformations. Okay, so why don't you try C to D, pause. It does say from C, so that's the larger one, to D. Oh, this one's nice. It tells us to include a reflection. So that was a nice little hint. And it does say tell whether they're congruent or they're similar. Well, just by looking at them, we can definitely say they're not congruent. So just go ahead and cross that off. They're not congruent. Congruent would be same size and shape, not just same shape. Same shape is only similar. We just need to see, can we change it so that they are in their spots. So again, nice thing is it does say to reflect. So pause here, see if you can do this to prove that they are in fact similar. Okay, so I'm going to dilate first because I know for sure it has to become smaller. So I should start there, right? Let's see if I can even get it down to size. So I'm going to dilate first. If you didn't, that's okay. So my size are 1, 2, 3, 4. Now it's 1, 2. This is 1, 2, 3, 4. It's now 1, 2. This is also 1, 2, 1, 2, 3, 4. So I cut it in half. Scale factor of a half. Remember my rule goes to half x, half y. I'm going to start there. So 2, 2 becomes 1, 1. 2, negative 2 goes there. This is that 2, 2 goes here. 1, 1 is actually going to go to a half, so it's a little difficult. It's going to go to a half. Here's these are a little off. Sorry about that. All of a sudden my pen is like not connecting to where I'm trying to draw, but there we go. It's a little better. So, okay, it's to size. So let's reflect it. I'm going to reflect. I wanted to flip. It does tell it to me to reflect, so that's nice. Reflection over y-axis. So xy goes to negative xy. I'm actually going to do this in another color. Hopefully you can see it. So it's going to go right here. Okay, there's my reflection. Oh, it's still not where it needs to be, so I obviously need a third sequence. And the way to do that is I just need to slide these 1, 2, 3, 4, 5 up. So I'm going to now translate up 5. And I'm going to put my rule right here just because I'm out of room. X, Y goes to, I didn't move my X's, but I did go up, so plus 5. So you can see sometimes you need them to have more than 2 sequences, and you need to say yes, similar, because I was able to shift them. Now, if you reflected first and then dilated, that is okay, because it should still come out the same way. I just shrunk it first because I knew I had to. All right? So we can talk about that in class too if you're confused by that. Okay, so this additional practice is a little different. It's going to actually have us practice applying sequences. So it's going to give us them, and we need to see if we can do it. Okay, so it says apply the indicated sequence of transformations to the square. Apply each transformation to the image of the previous transformation. So just like the ones we've been doing, we don't go back to the first one. We keep doing it to the one previous. So it's like a prime, double prime, triple prime type of situation. Okay? Label each image with the letter of the transformation. So instead of labeling them A prime, B prime, C prime, D prime, we would then need to just put A, B, C, D in them. Okay, so we're going to start with the square. They want us to make all the x's opposite. So this is a reflection, and that's y-axis, right? So make all of my opposites, all the x's. So if it's at 3, it's now at negative 3. It's at 7, so now it's at negative 7. And this is down here. And all they want us to do is then go A, like that. So we don't have to do these prime, double prime, triple prime, quad prime. They're just going to have us label them. So now we're done with A. We're going to go to A and make it rotate 180 degrees around the origin. So that's where, oops, so I was going to write the rule there for you. X, Y, remember, goes to both their opposites. Okay, so it's going to end up over here. So if I'm at negative, negative, I go to positive, 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 positive. And just maybe check, like that looks kind of big. Did I do something wrong? See, I'm checking it. Looks kind of big. Oh, it's at 4. There's why, see? Cut my square. There at 4. There we go. See, just check it every once in a while, make sure it's still the same size. And then I'm going to put a B here. Done. Okay, so maybe pause and you try to do C and D and see if yours ends up in the same place. Remember, we're going to now go to B and apply C. And then once you do that, you're going to apply D. All right, so pause, try C and D, and see if you get yours in the same place mine. All right, so it wants us to translate. So for C, we're going to go 5 down and 5 right. So 1, 2, 3, 4, 5. Oh, 6 down. 1, 2, 3, 4, 5, 6. Okay, to square 1, 2, 3, 4. So what I did is I just found, put a C right there. Made sure it was still square. Same distance, same everything, so it should be perfectly around the origin there. And then the last thing they wanted us to do is cut that in half. And so D should have ended up right there. And that's why I put that C up in that corner, because I knew that was going to happen. So check yours with mine, make sure it looks the same. All right, so not sure if there's much to remember, just remember similar. Size, change, same, shape, okay? All right, so this independent practice is a little different. You don't have to graph anything if you don't want to, but they want you to tell us what these transformations are causing them to do. So describe what happens to the figure when the given sequence transformation is applied. What's going to happen? So I can cut them for you. There's one here, then here. This is 1, 2, and then 3. So you need to describe in words what those rules are asking you to do. All right, until next time.